Why is bandwidth crucial for analog modulation? Imagine trying to listen to your favorite song on a radio station that's too narrow in its frequency range. The music would sound distorted or incomplete. That's because bandwidth plays a key role in how well signals are transmitted and received. When we talk about analog modulation, we are changing a carrier signal's amplitude, frequency, or phase to carry information. This process creates a spectrum of frequencies around the carrier, known as sidebands. The width of these sidebands is what we call the bandwidth. Having enough bandwidth is essential because it ensures all parts of the modulated signal are transmitted accurately. If the bandwidth is too narrow, some of the signal's frequency components are cut off. This results in distorted signals and loss of important information. For example, in amplitude modulation, the bandwidth needs to be twice the highest frequency of the original message. This is because the upper and lower sidebands each carry the same information. In frequency modulation and phase modulation, the bandwidth depends on how much the carrier frequency deviates and the highest frequency in the message. Carsons' rule helps estimate this bandwidth by doubling the sum of the maximum deviation and the highest message frequency. This way, the receiver can pick up all the necessary sidebands to reconstruct the original signal accurately. Bandwidth also affects how many signals can be transmitted at once without interfering with each other. If the bandwidth is used efficiently, multiple signals can occupy different parts of the spectrum, making communication more effective. This is especially important in crowded frequency spaces where many channels are active. Designing communication systems requires knowing the right bandwidth to avoid distortion and interference. Filters, amplifiers, and antennas are all selected based on the bandwidth needs of the signal. A wider bandwidth generally means better quality, especially in audio and video signals. For example, telephone systems limit bandwidth to only what's needed for speech, making efficient use of the available spectrum. In summary, bandwidth is vital for analog modulation because it determines how much information can be sent, how accurately it can be recovered, and how well different signals coexist without interference. Properly allocating bandwidth ensures clear, reliable communication and high-quality signal transmission.